Okay, a wire carrying 30 amps is suspended 5 meters between a shed, which is the power source, and barn through the Earth's magnetic field. So I'm just going to give myself a sketch here to start with. So here's my shed, and here's the barn. So the wire is going to extend a distance of 5 meters. So we're going to say it's fairly taut. We'll say for argument's sake here. So we know the length of our wire, since this direction is east. So that means that the length is 5 meters east. And Earth's magnetic field. So we know the magnetic field strength, 5 times 10 to the negative 5 Tesla. And a point at the wire where the wire sags makes an angle of 15 degrees to the horizontal. So I guess the wire is actually sagging. So I'll fix that up a little bit. So it sags. Wire is still 5 meters in length. It sags and it makes an angle of 15 degrees with the horizontal. So when we look at that, we now have all that information. What's A want? A is, what is the magnetic force that acts on the conductor? Well, magnetic force is Bill sine theta. So we know what the magnetic field strength is. That was given. Current was given, 30 amps. Length was 5 meters. And we know that the angle the wire makes is 15 degrees with the horizontal. So we know that that angle in there is the 15 degrees. Now the uniform field will be, since it's the Earth's uniform field, be toward the ground for us. So if it is a 15 degrees to that, we can just go ahead and use the 15 degrees then. So that works out all right. So sine 15, because it is the angle between the uniform field, so my blue lines, and the red line, or the part of the arc there. So we're looking at the angle here to here, and it's measured to the perpendicular. So that's why that 15 degrees works. So we punch that in, and we end up with, actually, now that I think about that angle a little bit more, it's not 15 that we want, because 90 is measured from that. So we actually want, that's my mistake, we want that angle there. So the theta that we're interested in, so let's go with theta 1. Theta of interest then will be 90 minus the 15. So that gives us 75 degrees. Because originally it's sine 90, so that's the angle we actually want. We want the angle with the vertical, not with the horizontal. Sorry about that. So making that correction, we find that we end up with 0.007 newtons of force. And we are going to talk about B part as the direction. So I'm going to take a step back here in 1 sec to figure out that. So B part's, what's the direction of this force in relation to the horizontal wire? Well, if you dangle your fingers in the direction, so that would be downward, the current is going to the right, then my palm would be against the smartboard, which means that it is into the board. Into the board would be the force, or towards the north. Because remember, we're looking at this situation standing on the south side of the buildings, because east would be to our right. So the force would be into the board, which would be heading north. And you can put into board or into page, or you can use north, either way. So that calculates the magnetic force acting on that wire that's being suspended. All right. Final example. And this is calculating B, a couple of examples with that. It's just mainly using the correct formula and making the calculation. So find the magnetic field strength in air. So it gives me the magnetic permeability 2 centimeters away from a conductor passing 5 amps if. So A is a straight conductor. So straight conductor, B equals mu I over 2 pi r. So straight from the formula, mu is given. Now, I don't know why they do 4 pi. It just seems to be the format that is provided. So when you do this, you got to be careful because you have to actually calculate 4 pi. So maybe I'll just go over here. Remember that 4, it's really 4 times pi times 10 to the negative 7th. So you might want to do that with the calculator. And I think what I've done in past years is I've just said that for the magnetic permeability of air, let's just call this 12.56 times 10 to the negative 7 and call it a day, rather than everyone having rounding to different decimal places. Then we have 2 pi, and r has to be in meters, so that's why it's the 0.02. So when we calculate that with the calculator, make sure you can get the correct answer. You should get 5 times 10 to the negative 5 Tesla. All right. Next, B part. What happens if it's looped 3 times with a radius of 4 centimeters? So this is the flat loop formula. So magnetic field strength is mu n I over 2r. So 4 pi times 10 to the negative 7th. It's got 3 loops. It has a current of 5 amps. 2 times, and the radius 0.04 centimeters. So you notice in this one, the 2 centimeters doesn't play a role whatsoever because of the looping. So when we calculate that, you should get 2.4 times 10 to the negative 4 Tesla. All right, and then the appropriate. There are 4 statements for each. And that gives you process on how to calculate that B value. So if it's not given, like it was in the previous example, we are given the field strength here, or its magnetic field strength. You may have to calculate it, or maybe its own question, and you just identify, what am I dealing with? Straight conductor, looped conductor, or solenoid? What are the appropriate values? All right, make sure you're using your EXP button again, and like I said, check to make sure you can get those with the calculator. So you move on and get those finished up. There's your homework for this particular section. If you have any questions, you know where you'll be able to find me tomorrow, and we'll see you then.